Okay, so let's get started again. All the videos are uploaded. So you go to the CAC 340 YouTube page, you'll see all the videos. And so you can practice, listen, whatever you want to do. I have uploaded another midterm. So these are some sample midterm 2 I have uploaded. We'll continue with our midterm review today. And also, so the midterm is tomorrow. Tomorrow during regular class hours. So we are trying to do this one, right? We are trying to do this, solve this problem. So let's continue solving this one, and then we'll see the next midterm, and that will give us a pretty much a good idea about what questions you can expect. Okay? So let's start analyzing this one. We didn't do this one, right? Last time we stopped here. Okay. So the first line of code when we execute int star star a. So the moment you declare any variable, you have to have a box and circle for it. So this is a. And since I have written that the comment memory alpha, it means that the address of a is alpha. So which means n% a is alpha. That is what it means basically. So we have declared a and becomes alpha, and then we have b. The moment we declare b again, it becomes we have to have a box and circle, and the memory address of b is beta. Then we declare c. C again box and circle. And its memory is gamma. We declare D again. So for each declaration we have a box and circle. And its memory is delta. Okay. Now we execute the first line of code, which is A is ampersand C. So what happens?
Value of A becomes the address of C.
Okay. So that means this becomes delta. Oh no, gamma. Sorry. This becomes gamma. So if that becomes gamma, then what is star of A?
The address of C.
Not address of C. It points to the value in the location C. In the location of C, right? So it should point to the value. It is not an address. Star of A points to the value associated with the location of C. Then we have C equals int star malloc size of int. So we have, the moment we have a malloc, we have to declare something in the heap. So let's say this is our heap.
Professor?
Yes.
I have a question. So, okay, so I get that star 8 points to the value. So on the exam, do you, when you draw this, do you want us to have a point to the circle or do you want us to have a point to the box?
No, to
Because
the
it
box.
Okay, because it just
Oh,
makes
right.
more sense to have a point to the circle if it's the
No.
value.
It has to be in the box. Why? Because star A is an L value. It's not an R value. So with respect, the definition of star A says that it has to be an L value. It has an address associated with it. Although when you do star A, you get the value as an output, but star A itself is an L value. So that's why you need to point it to the location. You cannot point it to the value. So do you understand that? Any other doubts?
So it returns an R value, but itself is an L value.
Yes. So you can do star A equals something. You can do. Okay. Okay. The next code. So C. We have to have a allocation in the heap. So when we have an allocation in the heap, the memory location is 1. Now what happens next? If we write that line of code,
We created pointer from C to the newly
to
created.
the heap, right? So basically that value 1 becomes the value of this at this location, and this points to the heap. So in this case, this value points to the heap, not the box. What is that? Right, so this value points to that location 1. Now we have b equals int star 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 malloc of size of int star star. So that is the moment we have that, we have a location in the heap with the address 2. So what happens? You take that address 2, write it here. And so okay, so this was star C, and this one points towards this location 2, it becomes star B. Do you understand all this, whatever we did so far? So far, nothing fancy. It was all simple. Right. Now we complicate a little bit. We say that star of B is ampersand C. What happens?
The value in star B becomes gamma.
Memory bytes to become gamma.
Exactly. So value at star of B, which means the value at memory box 2, becomes the address of C. So that is gamma. So if that is gamma, then this one points towards the location. So that means what is this? This becomes star of B. Right? And just so far that is what we have. And what is star of C? No, not 1. Star of C is not 1.
Oh,
It's the value inside 1.
yeah, the address.
Right? Star of C points to the location 1. But if you do star of C and try to access the value, you'll get this value, which is nothing. Now it's just garbage, right? Now you go to the next line, you do d equals 42. What happens?
The value for D becomes 1.
Yeah, that's simple. It becomes 42. Now you do go to the next line and say star of star b is 10. What is star of star b? So initially b is this. Star of b pointed to this. Star of b pointed to this. Star of b should point to that location. Right? Everybody understands? So this is equal to star of star b. Yes.
Why? I'm a little bit confused as to why that is equal to star B.
Yes. Let's see why. So when b was here, b's value was the address 2. Right? So what should be star of b? Star of b, if you want to access star of b, is the address. Oh no, it is the value inside this location 2. Right? So that value is gamma. Now that's gamma as an address. Right? So you can do star of that, because that gamma is a nil value address. So if you do star of b, then that points to this location, that location of c. Now again, star of b returns a location. Right? It is returning a location because it's one is an address. It's not a value, and it is a value, but it is an address stored in the value field. Right? So you can do star of that as well, because it's a location. So once you do star of that, you get this, and you get the value inside this. So that's why you apply star twice. So star of b is this address, then star of b is this address, and star of b is the value associated with this location.
So you basically default the pointers that you've created for B.
Yes, basically yes. So here we this is location 1. No, we did star of b is as 10. So which one is 10? The value in location 1 is 10. So you stop at location 1. So this is how it looks for location 1. So what are the questions now for related to location 1? Basically, we say draw the box and circle diagram for ABCD and draw and label star this. Okay, star A, star B, star B. Oh, there is a mistake. It shouldn't be star C. It should be star B. This is a mistake. This should be B. Right. So we have done that. We have done that. So first part is done. The second part is says that list 2 sets of aliases at location 1. So what are the 2 sets? So what is the definition of aliases? Two names for the same location, right? So what are the 2 sets here?
Star C and star B.
Yes. So you have a star C and star B. Then another set. Can you come up with another set?
Star A and C.
Star A and C. Is there any other set?
Star B and 2.
No, 2 you can. 2 is not a name, right? 2 is not a name. 2 is just an address. So whatever is in heap, there is no name associated with it.
Star B.
Star B and C. So basically the star A, star C, star B, right? Anything else? Nothing else. So these are the 2 sets: star C, star B, and star A, C, and star B. So you have to. This is the whole set. This is not two aliases. right? So this is the whole set of aliases because star A, star B, and C are the same thing. So if you just say star A and C, you won't get full points. Or if you just say star B and C, you won't get full points. You have to write all three. And also just writing doesn't work. You have to explain why. Why are they aliases? You have to show using this box diagram and say that okay, since they are pointing to the same location, these two names are aliases. Okay.
Why isn't star B in 2 aliases?
Because 2 there is no name associated with 2. 2 is an address, is something in the heap, but there is no name. So now aliases come into picture when we are trying to do name resolution. We are trying to associate a memory location with a name. So do you understand this? You have to explain. You have to write in words that this is why I think these two are aliases. If you don't explain, just write it, 0, no points. So keep in mind, because these are the silly mistakes that students do, and then they come back and say, oh, I didn't receive partial grades. You cannot. If you don't explain, you cannot receive partial grades. Okay, so now we move on. We have to move on to location 2. So let's take a picture of this and then we'll update. Yes.
On the exam, will it say to explain? Because it seems like something that would be easily forgotten. To explain.
Okay, I'll update to explain. I'll write in every question to explain. Okay. I'll first write explain and then write the question.
So for that one, would a good explanation be because star C and star B point to one location and then the others point to a different location?
Yes, you can say that star C, star B points to the same location, that is 1, and star A, C, and star B points to the same location, that is gamma. So that's why they are alike. Okay, so now we go to location 2. So there are a lot of things we need to do for location 2. So now we get star B as malloc. So we need another location. So we have to have another location. So let's location 1. So another location in the heap, and this heap location has the memory number 2 or 3, right? So now star B becomes that. So what is star B?
And gamma.
Yes.
Used to be gamma.
Star B has to be gamma. So which one changes to 3?
Value 2.
The value in gamma or value in 2? Value in gamma, right? So star B points to this location. So this one switches from 2, it becomes 3. Now if it becomes 3, then what changes? Star C and hence star B, right? So this link is gone. This link is gone. Instead, you now have a new link, that is this, and this is your star C. This is your star B. Yes.
This is for star B, not for star B. So would it be?
No, star B points to this location, and star B points to the value in this location. So there is a confusion with star, right? There is a confusion with star operator. You can have star A as both L value and R value. Depends upon how you use it. When it is on the left hand side of an assignment, then star A is an L value, and you are updating the value associated with the location in star A. So if you have let's say you had star A equals 45, then star A is the location, this one, gamma. And if you do star A equals 45, you update this as 45, right? So that is when you have star A in the left hand side of an assignment. If you have star A in the right hand side of an assignment, then what happens is that you take the value in this location gamma. So value is 45, and you treat that value as an R value, right? Do you understand this difference? When star A is in the left hand side of an assignment versus star A being on the right hand side of an assignment, right?
So the left hand side will change it.
Change the value associated with the location. So what is star A? Star A is a location. Star A is a location that has the address gamma. So if you do star A equals 45, you update the value associated with the location gamma. So you update 45 here. If you now do star A as a right hand side, use star A in the right hand side of an assignment, then what you do is star A is a location, you go to gamma and then take the value inside gamma and return that. Right? So when you use star A on the right hand side, then the value inside the location becomes is returned. Do you understand this now? Any doubts regarding this? So now we are using star star B on the left hand side, right? We are using star star B on the left hand side. So if you use star star B on the left hand side, what are you doing? You take star star B, so this is the location, you update the value inside this location, right? So you update the value with what? With this address 3. So you, instead of having 1, you have 3. So now this 3 is an address. It is an address which is being used as a value. Even if it's being used as a value, this is still an address. So you can apply star operator again on that address because it's a location, right? So you can apply star on star star B. So now it becomes star 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 B, 3 stars, and it points to the location 3. So which means if you do star 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 B, then you return the value here. If you use that on the right hand side, right? Then return the value here. Understood? Can we go forward? No. Now you do free B. So you have freed B. So what does it mean if you free B? What happens? Do you deallocate beta or what do you deallocate? Yes.
Do you deallocate the location that it's pointing to?
Yes. So you deallocate this one. So now this, instead of 2, it becomes null. It just becomes null. So you delete this link. So when you do free, that's what happens. So B, you free the heap. You cannot free the local variable because free cannot be used for deallocating local variables. B is a local variable. So whenever you do free, you basically are deallocating the heap location, right? So you deallocate 2. So this becomes null. Nothing is there. Now you say B equals again int star 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 malloc of int star star. So if you do that, then you have to have another memory location. And this memory location has the address 4. Yes.
Just to clarify, so free only applies to heap.
Yes. Free malloc, those things only applies to heap location. You cannot deallocate local variables using free. Error immediately. So now you do B equals int star star malloc int star star, and then you have the memory location 4. So what happens? You have a memory location 4 in the heap, and this becomes 4. So this was 2 initially. Oh, you did 3, so this becomes 4. And you have a link from this here to this. So this is now star B. Getting complex. Then you do star B is equal to another memory location. So you have to do another memory location. So this is now memory location 5. And you say star B you give, so star B is this value. So here you have 5. So this is now star B. Everybody understood what happened? Okay. And then you are saying star B is equal to C. So what happens? Yes? What? Gamma in 5. So if you have gamma in 5, now star B or star B actually. So star B points to that location. Or whatever value is there. Now what happens? Okay, everybody understands up to this point? Everybody? Is there any doubt? Yes.
When you free B, do you just only erase the line pointing to memory 2, or you have to erase the box?
You deallocate the box. But the thing is, different runtime environment might have different strategies. So what we do is we just cross out the line. We don't know what the other runtime environment is doing. So we don't tamper with it. Yes.
Do you get rid of the star C is equal to star B line as well? Since you have another.
Where star C equals?
From C to memory 3.
Oh, that one?
Yeah. do we
Okay,
keep that?
good question. Do we get rid of this line? Star C equals star B.
No.
Why not?
Because we didn't do free star C.
We didn't free that memory location. We only freed we only freed B. So which means whatever B was pointing to. So this memory is deallocated. These ones are not. Right? So we don't get rid of that. Yes?
Memory location 3 is no longer star B.
Yes, it's no longer star B. But still we cannot get rid of that. Yes. So let's remove this. Yes, it's no longer star B. But you cannot remove the link because you haven't deallocated. So now yes, what was I doing? Okay, we have to go to location 2. So in location 2, what changes? We go out of scope, right? We go out of scope. So whenever we go out of scope, local variables are deallocated, right? So which local variables are deallocated? C and D. So which means this one is no longer there. We cannot access this one, and this one is no longer there. Everybody understands this? Yes.
Why did you go out of scope?
Because that curly brace, we executed the closed curly brace. This one, we executed this one and came into this line. Now you answer the following questions. Location 2, list all memory locations that are garbage. So what does it mean by garbage memory locations? Pardon?
The ones that you didn't deallocate.
You did or did not?
Explicitly not.
Yes. So one memory locations which you explicitly did not deallocate and you cannot even access them. If you can access them, then that's fine. That's not garbage. but it's a memory location which you didn't deallocate, but you cannot access. So which memory locations are such?
Location 3.
Yes. Yes. So location 3 is 1 because C is gone, right? C is being deallocated and we cannot do star C anymore. So you cannot access. So location 3 is deallocated. So this is garbage. I mean, it's not explicitly deallocated, but still you cannot access it. So that is garbage. What others are garbage?
5.
1.
1.
Right. One at a time. Anyone choose to answer?
1.
1. Okay. 1 is yes. 1 is garbage. You cannot really access 1. What other? 2. Why 2 is garbage? Because there is no link to 2. B link is gone. So this is garbage. Is 4 garbage?
No.
5 garbage?
No.
So nothing else is garbage. Okay. So list all that are garbage. So again, you should explain. I'll put a note after every question to explain. Then you have to list all dangling references. So what did we mean by dangling references? What is the meaning of dangling reference?
So 5 is pointing to C, which got B allocated, so that doesn't make it garbage.
No, 5 is not deallocated.
Okay.
You can still access 5. Right? So 5 is not garbage in that case.
Wait, guys,
Wait, he has a question first. Yeah.
I was wondering when B being freed in the previous block make it so 3 isn't actually garbage. Because it's not still allocated, it was deallocated, so it's not making garbage.
No, if B is freed, then 2 becomes.
Or 2.
Oh, yes, 2. Yes, that's a good point. Good point. This 2 is not garbage. This 2 is not garbage because it was deallocated. And you did free B, remember? 2 is not garbage. 2 was deallocated. So this is deallocated. That's a good point.
So would that make 2 then?
2 as?
Dangling.
No, dangling reference is again name. You cannot have memory as a dangling reference. It has to be a variable name.
Star, 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 B is dangling.
Star, star, star B is dangling. Yes. Star, star, star B is dangling. Why? What was the definition of dangling reference? What did we say? That what is the dangling reference? Yes. When you have deallocated some memory, but still you can access it. Then you have some way to access it, but it has already been deallocated. So if you go to star, star, star B, it points to C. C is deallocated, but still you can do star, star, star B. You get the value at whatever this location is. This is in stack, so whatever value was that in that particular stack location, you'll get it, right? But it is garbage value because you deallocated C. So this is a dangling reference. Any other dangling references? Yes. Any other dangling references?
Star A.
Star A, yes. Star A, you have deallocated C. So star A is again dangling. Anything else?
Star B.
Star, star B. Star, star B, is it dangling?
No.
Why not?
Because it's going to 5.
Yes, it's going to 5. It didn't deallocate 5. 5 is still there. Right? So star, star B is not dangling. I don't think there are any other dangling references.
Can you list all of them again?
So dangling reference is star, star, star B and star A. And garbage in memory locations are 1, 3, yes, 1 and 3, and deallocated is 2. Only 2 is due. Yes.
When did we deallocate C?
When we did free B.
We free B, no, I think that's asking for when we deallocated C. That's just when we had out scope.
When we deallocated C.
Yeah.
Oh, okay. So when we went out of scope.
When we went out.
Yes. But if you go out of scope, you deallocate the local variable. So this C was a local variable here, D was a local variable here. So the moment you get out of this closed curly brace, then you deallocate those local variables. Yes.
So what is a good technique in the paper you're writing an exam? Do you just cross out or do you try to erase?
You can cross out, but anyways, it's getting complex. Like this also, if I see, I will get a hard time to analyze.
Yeah,
So
you just want like the final, what looks like.
So what you do is for each location have a separate box and circle. That's what you should do. For each location have a separate box and circle. So at the end of the location, I would know exactly what you did. So you start from location 1, and then whatever things you have crossed out in location 1, don't use those arrows again. Right? Just the arrows. Have those memory locations. Don't erase the memory locations. Just erase the arrows. Yes.
So you said there was gonna be scratch paper at the end of the test. If we did our work there, just put what we, the end of what we got to at location.
That's fine. Just have a line that okay, work is shown in that page.
Okay.
So for location 2, would you like not even draw C and D?
No. Location 2 should have C and D because in location 1 there was C and D. So whatever was there in location 1, keep it. Whatever you crossed out in location 1, delete it. And then in C have everything. So yes.
Can there be a dangling reference to something that to a value that wasn't set in the first place? Like if it was
The dangling reference has to be to a memory location. It cannot be to a value. It has to be a memory location.
okay, never mind, yeah, that makes sense.
Any other questions? Yes.
When did you allocate the memory to?
When?
Yeah, I mean, memory to when it's.
Deallocated when we did free B. Because B was initially pointing towards 2, right? So we did free B and 2 got deallocated.
So all the references from B will get deallocated.
Not all, just that one reference to 2.
No, I'm saying technically there must be multiple references.
How can you cannot point to multiple locations? One variable, one name will be resolved to just one location. You cannot have multiple locations.
Okay, so that one just gets deallocated.
Any other questions? This is probably the most difficult question in the exam, right? So we solved that. That's good. The midterm. This was midterm 1, the first midterm, first example. So we finished this. Any doubts in any of the questions that we had so far in this midterm? Yes.
Is it pointing to the memory 2 or pointing to the memory 1?
Now it is pointing 4, but previously it was pointing at 2.
Oh, okay.
We have crossed it out. See, we have crossed it out. And now it is pointing to 4. Okay, so let's yes.
Small question, how would we interpret, n percent,
Ampersand.
n%?
So can you give me an example? Then I can show. Let's say. Okay. Can you have ampersand C? Can you have? So when do you when do you apply what do you apply ampersand to? Pointer, but it has to be a name, variable name. Right? It has to be a variable ampersand C or ampersand A, B, C, D, whatever. You cannot apply ampersand to an address. You have to apply ampersand to a name. So you cannot have ampersand C, because ampersand C is not a name. It's not a variable name. It's an address. You cannot apply that to an address. You can only apply that operator to a variable. So you don't really have ampersand C. You can have star C. Star can be applied to a location. It doesn't need to be a variable.
So it's if it's in the code, it's not valid.
Any other questions?
When we calculate first and follows and we have our sets, is there a way to, at that point, use those sets to figure out if we did it right and if we have all the right members in the sets, or like a way to double check ourselves?
I don't know.
Like working backwards, you know? Yeah.
So what you need to do is you need to see what else can you include in first set. So let's say first of a non-terminal has AC, and you have some other non-terminals or other terminals which you potentially want to include. So what you do is you check all the rules and see whether A can start with that terminal that you haven't included. If A can start with that terminal, then I think you're wrong, right? So that is one way. So that's a good question. How do you check? How do you check if you have done the first and follow sets correctly? So in order to check first sets, what you do is after you have done all the computation, you have a set of first sets, right? Go to each non-terminal, follow every production rule. You see that first set, it has some terminals. Now you have a set of terminals that can occur for the entire grammar. That is a comprehensive set of terminals that you know, all the sets of terminals. So you now find out terminals which you have not included in the first set of that particular non-terminal. Right? Now you check, you go to every possible production rule for that particular non-terminal and see whether this non-terminal can start with the terminal that you haven't included. If it can, then you're wrong. If it cannot, then that's good. You're fine. Right? For the follow set, same thing basically. You see whether you have included, or you see which terminals you did not include in the follow set, and then go through all the production rules and see whether a particular terminal which you have not included can follow this non-terminal. That is the only way I would say.
Can you also have like cyclic references when you're completing first set?
Cyclic reference?
As in like A goes to A and then something else, but so A is going to A, so you come back
Yes,
again.
yes, you can. But even if you have that rule, then if you apply multiple times, the result will be the same, because you are doing union. Right? Union, you don't really have to include A twice or B thrice. You just include it once. So even if you have that cyclical rules, you just apply it once. Any other questions?
About the homework assignment, when we are trying to find out tokens for some script, do we need to help people with the match potential longest string? Okay.
So homework was due when?
It's due tomorrow.
It's due tomorrow, so we cannot discuss homework. But let's discuss in the next midterm that I have posted. We have some similar examples as it was there in the homework. So this is the midterm that I posted again. No, this is midterm 2 or which one? Yeah, this is the same one. So let's go to sample midterm 2. So here this is sample midterm 2. We have a question that is very similar to the homework. Right? Is it the exact same question or not? In the homework, do you have this exact same question? It's different. Right? So we'll discuss this. Okay, so this is our regular expression, a set of regular expressions. Now, for each of the following, fill the blank in with belongs or doesn't belong, right? Ideally, belongs, doesn't belong, you have to explain. But for this particular question, I don't require you to explain because it gets monotonous after a certain point. You end up saying the same thing again and again. So you don't really have to explain for this type of question. So what you do is, okay, so let's go and see whether these are there or not. So A44, does it belong to the language of alpha? So alpha is this regular expression. And these are the terminals. A, B, C, D, capital A, capital B, capital C, D, and 4, 5, 6, 7. So A44, does it belong to alpha? Language of alpha.
Is it letter star?
Pardon?
Is it letter star?
Letter star means what? You can have 0 or more A's. Right?
No, I just can't see very well.
Oh yes, yes, that's letter star. Yes. Okay, I can make it bigger.
Wait, yeah.
Now better?
Yeah.
Yes, so A44. Yes, does it belong? A44?
Yes.
So how does it belong? So you can have a letter or a digit as the initial one. So let's say you have a letter, that is A, you map this letter to A, and then digit star, so you can have multiple digits. So digit has 4 in it, so 4, 4, and then you have letter star, which means you may or may not have a letter. So it matches alpha. And everybody understands that it matches language of alpha. Now say 47, does it go to row? 47. Does it belong?
Yes.
Yes.
It does. Why? Because you can have this digit 4, and here this is letter digit star, so it can have either a nothing, or it can have a digit, or it can have a letter, whatever combination. So 44 is in row. So let's write this down. So we'll just write the sequence of belongs and doesn't belong, and you can copy. So both belongs. Does 47 go to 5?
No.
Why not?
It should only one digit.
It can only have one digit, so it doesn't belong. Then does 74 go to omega?
Yes.
Why?
There were two digits.
You can have 2 digits 7, here this one, and then here it can be letter or digit. So 4, you choose the digit, and here it doesn't have to be letter. So 74 belongs. ADAE, all caps, does it belong to alpha?
Yes.
How? Says no. Why not?
E.
Can you scroll up, please?
Yes.
Can you scroll up so you can see the letter row? Okay, then no.
No. Yes.
No.
Why not?
E.
Yes. So E is a terminal which is not in any rule. So ADAE does not belong. Although it seems if he was here, it would have been there. It would have belonged to language of alpha. But since A is not there, it doesn't belong. This is a tricky one. Everybody understands why it doesn't belong? Okay, this one. A, capital A, 4D, small a. Does it belong to row? So this one. Fine. Why not?
N goes small a.
What?
Small a at the end of it.
Okay, so you have to end with small a. Can it end with small a?
No.
It can end with small a. If you just have small a, will it be in language of row? If you just have small a.
Yes. Yes.
Yes, so it ends with small a also. But in this case, if you have a small a, then it should be just one number, one symbol. It cannot be multiple symbols, right? But in this case, we have multiple symbols: small a, capital A, 4D, small a. So in that case, it cannot end with small a, right? So that's why that does not belong. Now ADA47, does it belong to 5?
Excuse me?
Yes.
What if the A AA40A doesn't have that final small a? Is it belong to the LB?
Row, the 5.
Yeah.
This one.
I mean, what if it doesn't have the last small a?
Okay, what if it doesn't have the last small a? Will it be there? If it doesn't have the last small a.
Yes. Yeah.
Yes, it will be. But since it has the last small a, that's why it does not belong. Any doubts? Do you have any questions? Anybody has questions? Okay. So let's do this one. AGA47. Does it belong to 5? Why not? It can only have one digit. So it does not belong. Then we go to, oh, this is the last one. So 4 small a, small a, small a, small d. Does it belong to omega?
Yes. Yes.
4 y.
Yes.
Why does it belong? It has to start with a digit. It starts with a digit. It can have a capital letter as the second one. Capital letter or a digit as the second one. It has capital D. And then letter starts, so any number of small letters. So that one belongs. So that is the correct sequence, right? So you can note this down. Yes.
So does the parentheses actually matter? I know it's just
Which parenthesis?
on the rule, if you scroll up.
Yes, the omega has parentheses.
No, I'm talking about like the first one, like A44.
Yes.
So if you go up to the rule says parentheses, letter, and then or, and then the whole thing is star. So is there a difference between the whole thing star and then just the letter or the star?
Is there a difference? So what is the language of what is the difference between these two?
None.
No difference. Because we know that language of, according to the definition, if you go to the slides you will see language of this is same as this.
So for number 4, if you look at rule 4, it says digit parentheses star. Does the parentheses actually matter?
Okay. This one versus is it, these two are different or same? Are these two different? Different? Why?
Concatenation as precedence.
Precedence. Concatenation as precedence. When you use open and close braces, these are together. You cannot separate these. But if you do not use, then you don't know which one to apply before. So in that case, precedence takes over. So dot has precedence. So this, the language of this will be language of letter union language of digit dot digit star. Right? These two are equal. But this one is equal to language of letter or digit concatenation of language of digit star. So this concatenation means is the Cartesian product. Right. So those two are different. That's how.
No, I get that, but why is there a parentheses for digit in the middle?
Oh, that you can eliminate. That
That's what I
you.
was saying.
Oh, okay. Yes, that you can eliminate. Any other questions? Yes.
How would you want us to do problem 2 on the midterm example 1?
What was wrong with
Midterm.
midterm? This one? Problem 2 is? Okay, so this one, what you do is you go to the slides. You go to the slides and that was it, semantic analysis. Just write these. The code in that form.
What slide is that?
Slide number 42. So every function should have all this. Right. Just follow this slide, this format. That's how you need to write. Yes.
This lecture video gonna be uploaded by tonight?
It's all uploaded. Just go to the YouTube channel.
Like the one that we're recording right now.
Oh yes, I'll do that. Okay, so that's how you should write the code. I'm just not writing it because it's all mechanical. Just follow the slide, you will find the solution. Any other questions? Okay, so let's go to the part 2 of example 2. This one, part 2 says, any question? Part 2 says if we call get token repeatedly on the input this until the end of the input is reached, what will be the sequence of tokens? Right? So we have this rule. So tokens can be letter, capital letter, digit, or alpha, rho, p, or omega. Any of these 7 things can be the output. Right? So let's see. So for this we need to do the longest prefix matching algorithm. Right? So let's apply the longest prefix matching algorithm. So how did we do it? We have a table. We have a table which has the string here, then it has the match, potential matches, and longest match. Right? So initially the string is what? 4, 7, A, D,
Is capital.
capital D, then capital A, 4, small d, 4. That's the string. The header is initially here. Right? There is no match, no potential. Potential is everything. Right? No longest. Yes. Oh yes. So initially you go here. This is the first one. So what is the match? Yes. What is the match? Yes. Alpha is a match. Rho is a match. Rho is a match. Then phi is a match. Yes. Anything else that is match? You're forgetting the first one. The digit is a match. Right? Digit is a match. Digit, alpha, rho, and phase. Right? All these are matches. Now, what are the potential matches? What could potentially match? No, these are matches, so you won't include that in potential. These are already matched. So what are the potential matches? So only what is left? Omega. Is omega a potential match? Yes, potentially it will match, right? What is the longest match? What do you take as the longest match? Digit. Remember, these are tied, so whichever is defined first. So digit is the longest match, and the length is 1. Everybody understands this, right? Yes.
Do I have to do it like this on the test, like your table? Because I have my own way of doing it. That's exactly the same as you do.
I would prefer you do the table, because if you go your own way and you're wrong, then that's
It's the same
sad.
thing, it's just written differently.
No, that's fine. If it's written differently, that's fine. Yes, that's fine. You can find your own way of doing it. Okay, now you go here. Now you have 47. Does it match digit? It does not. Why it does not? Because the token is now 47, not 4. If it would have been 4, it would have matched digit. So it does not match digit anymore. But does it match alpha?
Yes.
Yes, it still matches alpha. Does it match rho?
Yeah.
Still matches rho because it's digit and digit star, so it can be digit as well. So it still matches rho. Does it match phi? No, because if it starts with a digit, it has to be a single digit for phi. So it doesn't match phi. Can it match omega?
Yes.
Yeah.
Potentially omega, yes. So what? Yes, question.
Wouldn't it match?
The 40
It's already matched.
It matches omega. Yes, it matches omega. Right, it matches omega. That's a good guess. So there is no potential. We don't need potential. What is the longest match? Alpha and psi is 2. Right. Now we go to the third one. Is there any match? Does alpha match?
No.
Alpha does not match. Does rho match?
No.
No.
Because it's a lowercase.
It's,
Oh, it's a lowercase. Yes. So rho does not match. Does omega match?
yes.
It matches. Okay. Yes, because letter star, right? So omega is the only match. There is no other potential match. So longest match is omega, 3. Right? Then you get another small a. Does omega match? Because there are no other matches, so I don't care about other things.
Yeah.
Does omega match? Yes, it's letter star. As long as you get small letters, omega will keep on matching. Again, you get another small d. So still omega matches. Now you will get a capital D. If you get a capital D, does any of the letters match? Or nothing matches, right? So you have 0 match. No match. No match, no potential match. Longest match is omega comma phi. So what you do?
Great. And
Yes.
get chart.
Yes.
And get chart.
And you say that okay, omega is the longest match, right? So you output that first token that you get is omega, and then you go back to unget chart. Right? You go back. Yes.
So we don't keep omega's potential in those three steps.
No, potential is already matched. So it's not potential. It has already matched.
Either here or there.
Yes. So the first output is omega. Everybody understands this? Okay. Now again you do from the rest of the string, wherever you left off. So you again do get car. You get capital D. What matches?
Capital letter.
Capital letter matches. So you get letter. Then alpha will match. No, does alpha match? Yes, alpha matches. Yes. What else matches? That's it. Right? Nothing else matches. Yes? Phi matches? It doesn't match. It's letter star, but digit, you have to have a digit. So phi does not match. What are the potential matches? Phi is a potential match because it can have letter, it can start with a letter. So phi is a potential match. Omega? Can omega match? It has to start with a digit, right? It didn't start with a digit, so omega doesn't match. So what is the longest match? Letter. Letter and the length is 1. Then you get a capital A. Letter does not match anymore. What matches? Does alpha match?
Yes.
Yes, because you can just skip the digit because it's digit star, and you can just go to letter star, right? So alpha still matches. Does phi match, or is phi a potential match? No? Yes, it's potential. It's letter star, so it can have as many as capital letters as possible. So alpha, phi still matches. Longest match is alpha, size is 2. Then you get the number 4. Does alpha match? Not anymore, right? Alpha does not match. Does phi match? Phi matches. Is the omega potential? No, because we have already eliminated omega. So now what is the longest match? Longest match is phi and size is 3. Now you get a small letter a, right? So this is small letter a. Does phi match? No, nothing matches, no potential. So one moment you get this, no match, no potential. So what you do? Longest match was 5, 3. You output 5. You output 5, and then you revert back. You get unget chart here. Right. Now you again do get chart. If you do get chart, you come here. You get A. Small letter matches, right? What else matches? Anything? Any match? Row matches because it can start with a letter and it doesn't have to have anything else. So row matches. Alpha does not match. It has to either start with a capital letter or a digit. Phi does not match because it has to start with a capital letter or it can be just a digit. Omega does not match because it has to have a digit, right? What is a potential match? Alpha is a potential match. Can alpha be a potential match?
No.
Because it has to start with a capital letter. So no, nothing potential. What is the biggest? Small letter with size 1. Then you get another small letter which is D. So now does letter match? The letter does not match. Does row match? Row also does not match. So no match, no potential match. The longest match is a letter, which is 1. So you come back, do unget car, and you output is a letter, right? You could have outputted a row also, but row is defined later than later, right? So that's why you define as output later. Then you again you have do a get car, you get small d, later matches, row matches, nothing potential, maximum is later size is 1, right? Then you get the digit 4. Later does not match. Does row match?
Yes.
Row matches. With no other potential matches. So you say row 2. Then you do another get card, you get end of 5. So you stop there, you output that this is row. So what are the sequence of tokens you got? You got omega, you got then phi, you got then letter, and you got row. Those are the tokens that you got. Right? So that's how you should do that one. Any questions? Any questions? This is not it. It's today.
Why is the last two is the letter instead of row?
Which one? Oh, because the letter was defined earlier than row.
Okay, you mean
In there. See, small letter is the rule 1 and row is rule 5. So it's different. Row is defined later.
okay, so if a row is defined earlier, so we use the earlier one.
Yes. If in case of a tie, that is the priority that will be. Okay, any other questions? So then we go to the second question. Second question says, consider the following grammar. Find a string with 2 different parse trees and draw the 2 parse trees. Can we take like 1 or 2 minutes and try to find a string with 2 different parse trees? Yeah.
I have one. Or do
Oh, you have one. Okay, let's have that one. So what is the string?
FG.
Yes, what is it?
FG.
Capital or small?
Small f.
Oh, it has to be small. Right? Yes. Small f, small g. Okay, so we have small f, small g. So what are the 2 parse trees? How can we parse it? This should be simple. So you have to have the root as the start symbol. And what rule do you use? First you can use the simple one, that's rule 2, right? So you say that S you divide into capital F and capital G. Capital F has the rule small f goes to capital F, right? So you can go small f, capital F, and then it also has the rule epsilon. And then G you can, so G goes to small g, there is already a rule. Right, so that is one parse tree. Right. Another parse tree you can do is you can have S, and let's say we take the first rule that you have go to D, then you go to F, then you go to F, small g, capital G, right? Then what you do, capital D, there is a rule that says capital D goes to epsilon. Then there is a rule that says F goes to epsilon. Then use the rule F goes to small f, capital F. Use the rule F goes to epsilon. Then use the rule G goes to epsilon. So 2 parse trees for the same string, FG. Right? You can maybe find out some other strings. That's fine. Any doubts on this one? Yes.
Doesn't G go to small d? Or
G goes to
to small d?
No, it can go, but I'm choosing not to use that rule. You have to find one parse tree in a way that you can parse that string SG. You don't have to use the rules in sequence. So use whatever rules that gives you that string. Right? Yes.
I think there is just like confusion between the regular expressions from the previous question
Oh,
and
and
this because these are just different like rules. They're-
these
it's
are
just,
yes.
like,
So
four
this is a
rules.
context-free grammar. This is not regular expression. So that is a distinction that you need to make. So two things: regular expression, context-free grammar. In regular expressions, we have kind of the similar expressions, right? We have similar expressions, but here we have equal to. Instead, in context-free grammar, we have arrows. So when you have arrows, you consider that as context-free grammar, not regular expressions. So in case of context-free grammar, if you want to parse a string, use whatever rule that is there in the production rule list. You cannot make up your own rule. You shouldn't make up your own rule. You just stick to the rules that are given, right? But use whatever to find out or to represent that string. That's how you parse. Okay. So any other doubts in this one? Yes.
So you do the first tree to figure out if it's a context free grammar, right?
No.
No?
Every context-free grammar will have a parse tree. You do the parse tree to figure out what rules will you use in order to parse a particular string. Okay. And then you also use parse tree to show whether a particular grammar is ambiguous or not. So in this case, for a string, you have two different parse trees. So this grammar is ambiguous.
But it can still not be ambiguous.
Now, if you have two different parse trees, then it is ambiguous.
But if you can't find them, then it's not ambiguous, it's not a COG.
It's still a context-free grammar.
Okay, but it can be not ambiguous.
Yes.
Okay.
Now, calculate first and follow. I'm not going to do it again. Just do it at home. That should be fine. We have already seen one example. Okay, this one, design a regular expression called IP to match IPv4 addresses. So an IPv4 address is composed of 4 octets, right? Separated by periods. So dot dot, right? Each octet is an integer between 0 to 255, and these are inclusive. So 0 is also there, 255 is also there, and it should not have any leading zeros. Yes, you are familiar. So represent a regular expression that matches the symbol dot as slash dot. So dot means slash dot. Okay. So yes, so as to not confuse it. So can you write a regular expression that will match an IP address? So what you have to do is you have to have an integer between 0 to 255. So how can we represent an integer between 0 and 255? Can we write the regular expression for that? So first of all, in order to do that, okay, do we need a picture of this or this is fine? So then just take. So first we have to represent the digits. So how many digits do we need if you want to represent between 0 and 255? Pardon? We need all of them. Okay. So now we have digit. So digit equals 0, 1, 9. Right? 1 through 9. Then we potentially need p digit, right? Because we don't want any leading zeros. If we don't want leading zeros, then we need to have p digit. P digit is what? Is all positive digits. So it does not have 1, does not have 0 in it. So 1 through 9. Right? Now we need to represent a number between 0 and 255. So how can we represent a number between 0 and 255? Yes.
Separate by tens and
Oh yes, that's what we have to do. So what we do is we can write another p digit 2 as 1 or 2, right? Then what we can do is we can write the num or integer. We need to write integer. Integer 255, so that is the maximum, is p digit 2. So first let's write the numbers which have all 3 digits. There can be numbers which do not have all 3 digits, maybe 1 digit, 2 digit and so on. But for the numbers that have all 3 digits, that means they can range from 100 to 255, right? That's what they can range from. So in order to do that, we need to write digit 5, which is from 0, 1 to 5, right? Then we write int 255. So first we say, okay, we can only get the first, if it is a 3-digit number, the first integer has to be p digit 2. It can be either 1 or 2, right? It can be either 1 or 2. The second digit can be digit, third digit can be digit, right?
Would it be 5?
Yes.
Would it be digit 5 instead of just digit?
So there is a problem.
So, because
If it starts with 1, then all those digits can be anything, right? It can be anything. If it starts with 2, then this one has to be digit 5. And the next one can be anything. No.
you can stop at 4.
What? Yes, we could stop at 4. So we have a digit 4.
Is 255 inclusive?
Well, wait, digit 5 includes all of that.
Yes, includes 0 through 5.
So you would need, so you can keep it digit 5.
We cannot. Because
So wouldn't it go 2 digit 5?
no,
It can't be over 255.
it cannot be over 255, but it can still be 249.
Well, no, that's what I'm saying. Couldn't it go to digit, which is 0 through 9, and then digit 5, which is 0 through 5?
Then if you have 295.
Okay.
So it's kind of tricky. So we have to have a digit 4. Where do I write that? Maybe somewhere here. We have a digit 4 through 4, right? So here we have to say that this is digit 4, then we have digit, right? Then we have 2 digit,
25.
pardon?
2,
What?
5 and digit 5.
2, 5 and digit 5, yes. But this doesn't solve it yet because we don't have 2-digit numbers. So for 2-digit numbers, we can have p digit, and for single-digit numbers, we can have digit. Right? This makes sense? Yes.
Do you even need to define PWT then? You can just say
Oh yeah, we don't even need to define PDG. Yes. So instead of defining P digit 2, let's define digit 4. Now we define the IPv4. IPv4 is int 255 slash dot int 255. That's it. Right? So that is our IPv4. We don't have enough time to finish the other two. The other two are, oh no, that's the end. That's good. So we are done. Yes.
Sorry.
I don't know. I don't go to that.
Yeah, just sheets, it could even be timed. So not two sheets, one sheet on two sides. Okay. But it was.
Yes, it was a match.
It was potentially like late night.
Yes, initially.
Yeah, why was it not?
It can start with.
But it has to have.
Go chase it down.
So I know what that is. Star, I know what that is. Well, sure, but I mean, I know like for this one, you can always, you just keep having A, B, and A. So it doesn't matter what combination, this one, you can pick one, but you can have a bunch of them. But what does that mean?
That means you can have information.
So it's just,
So it's like,
so these are the same. So it's mostly like this then?
yeah, it's mostly like that.
But how is it?
Because you can have name, or you can see it in and I get any solution.
But what do you mean any type of B? Because there's
Or B, and then you can have, B.
but you can for this too. You can have A, B in any combination for each.
Yes, yes, that. So what you do is you just check that first say, just check straight for the people.
Yeah, I have that. Yeah. Okay.
So then you have to check for a
Yeah, I just don't understand.
I think in both expressions you can have any number of A or B in any combination, so I think it's works.
I mean, to me, with my knowledge of it, that's what I thought, but I'm not sure. So I have to ask if there is one of these in there.
If it is somewhat different, like in example, step would be arrive at the right.
That's fine. If we arrive at the right, yeah, that's fine. If we arrive at the wrong, then that's the problem.
Is there any difference between this and? Is there any difference between this and this?
You can,
To me, they're the same, but I don't know, I'm not sure, because there is one of these in the homework problem, I'm not sure.
oh, so then I cannot tell you.
Oh, really?
It's,
Oh, okay.
kind of,
Oh, man, okay. Thanks, I guess thanks.
So,
I guess I'm just gonna treat it like the same thing. I don't,
Yes, tell me what's
so about project one in CSE 330.
Oh, 330 or
So I used the G++ command to compile it because I thought that was compiling it in C code because I have code in C before. So
You wanna
it
get a
appears
study
it
group too?
isn't.
yeah,
So
well,
I'm
you
trying,
have to use
I have to eat
so I'm
first, I'll
trying to
start it.
convert
Oh,
to
yeah,
C++
for sure.
code.
Yeah, right after that, I need to study. I started doing more
Encountering one
because
error.
it doesn't matter, it's just.
Same way your conflicts
I
are.
was thinking it's more important to do it like.
Okay, thank you.
I've lost count of how many times my stomach growled.
Oh, yeah. Always.
Oh, but today I will be busy until 2.
Well, yeah, just text me, the best place is always.
Today I will be busy until 2:30.
Okay,
After that it is.
and room 517.
Exactly.
Thank you.
Yes.
So the